Welcome back to AI CodeCast, your daily dose of coding challenges. You know, the ones that make you feel like you're in a real-life action movie.
Oh, absolutely.
Well, today's problem is called Diffuse the Bomb, and it's as exciting as it sounds. Picture this. You're staring at a bomb, the timer's ticking down, and the only way to stop it, to defuse this bomb, is to crack this code. And wouldn't you know it, it's in the form of a circular array.
A circular array.
Yeah.
Okay, so what makes this so special?
Well, in a circular array, if you move past the last element, you don't just hit a wall, you circle right back to the beginning. Think of it like a loop, or like, you know, those circular train tracks?
Okay, I see where you're going with this. So we have the circular array, this code for the bomb, and then there's got to be some kind of key to figure out how to, like, actually defuse it, right?
Exactly. We have this key, denoted as K, and it basically tells us how many positions to move, either forward or backward, to sum the numbers in the array to, to get the code.
Interesting.
If K is positive, you move forward.
Yeah.
Negative K, you're moving backward.
Okay, makes sense so far.
But here's where it gets a little tricky. If K is 0, the entire array, it just becomes 0.
Wow, that's almost too easy.
Yeah, if only real bombs were that simple.
Right.
But let's dive into an example to really see how this works.
Sounds good.
Let's say our code, our circular array is 5, 7, 1, 4, and our key is 3. Walk us through how we'd actually decrypt this, defuse the bomb.
Okay, so since our k is positive 3, we're going to move forward in the array. So starting with our first element, 5, we add it to the next 3 numbers. 7, 1. And then remember that wraparound we talked about? We go back to the beginning and add 4.
Right, because it's circular.
Exactly. So
Yeah.
that sum, which is 17, becomes our first decrypted value.
Gotcha.
Then we move to the next element, 7, and repeat the process.
Okay, I think I'm getting the hang of this. But wouldn't this get really tedious if we had a massive array to deal with? I mean, we'd be doing so many calculations.
You're absolutely right. This is what we call the brute force approach. And as you pointed out, it can be quite inefficient, especially with larger arrays and different k values. And that brings us to another crucial aspect of this challenge, something to really watch out for: potential pitfalls.
Pitfalls, like what?
Well, the time it takes to calculate everything manually is certainly one, as we just discussed.
Okay, yeah, makes sense. What else might trip someone up?
The wraparound.
Ah,
Forgetting to handle that correctly can be a common mistake. It's easy to accidentally go out of bounds when you're moving through the array, especially with negative k values.
right. You got to keep that circular motion in mind.
Exactly. And another pitfall is not considering the efficiency of your solution, especially in an interview scenario. Just presenting a brute force solution, it might not be enough.
So you're just saying there's got to be a more elegant, a more efficient way to tackle this, something that really shows off our coding skills, right?
Exactly. And to start thinking about that, consider this. What if instead of recalculating the sum for every single element, we could somehow reuse our previous calculations?
Reuse. That sounds promising. Is that where the sliding window technique comes in? I've heard that term thrown around.
Yes. It's all about strategically reusing those calculations as we move through the array, like sliding a window over the numbers. But we'll dive into the details of the sliding window technique in the next part of our deep dive.
Ooh, a cliffhanger. All right, listeners, we've uncovered the brute force approach, but there are smarter, more efficient ways to defuse this bomb. Stick with us for part 2, where we'll unlock the secrets of the sliding window technique.
Welcome back to AI CodeCast. In the last part, we were talking about the Diffuse the Bomb challenge, and, we explored that brute force approach, right?
Yeah, we definitely saw how that could get pretty tedious.
Yeah, especially with those big arrays. And we also touched on some common pitfalls, and I think, if I remember right, we even hinted at a more efficient technique. What was it called?
The sliding window, that's the one. You got me all curious about how it actually works.
Of course. So imagine a window, right? But this window, it's the size of our key, our k, and it's sliding across the array. So now, instead of recalculating the sum of, k numbers for each and every single element, we just focus on updating the sum at the edges of this window as it moves.
So it's kind of like we're reusing the sum from the previous window and then like adjusting it based on what elements are entering and leaving.
Exactly. It's all about that reuse. Let's go back to our example. Remember, the array was 5, 7, 1, 4, with k being 3. So our initial window, it would cover the first 3 elements, 5, 7, and 1. We calculate their sum, which gives us 13.
Okay, so that 13, that becomes our first decrypted value.
Right. And now we slide our window 1 position to the right. So the element 5, it leaves the window, and 4, it enters. Now, instead of summing all three elements again, we simply subtract 5, 4 from our previous sum, which was 13, and then we add the 4. This gives us 12, and that's our next decrypted value.
Ah, I see. So we're basically reusing a big part of the calculation from the previous step, which saves us a bunch of time and effort.
Exactly. And this efficiency gain, it becomes even more noticeable when the array size and the value of k increase.
This is pretty clever. But I'm wondering about the wraparound effect with the sliding window. How do we manage that? Because what we hit a snag when our window reaches the end of the array?
That's a great question. And the way we handle the wraparound is by extending our original array. We simply tack on the first k elements to the end of it. This extended array ensures that even when our window hits the end, we still have all the elements we need to calculate the sum without, going out of bounds or anything.
So it's almost like we're creating this virtual circular track, and our window just slides along it seamlessly. Pretty neat.
Perfect analogy. And remember, the sliding window technique works for both positive and negative k values. The core logic stays the same. We just need to adjust the direction our window moves in.
Right. Positive k, window to the right. Negative k, window to the left. So we've covered the brute force approach, and we've now gone over the sliding window technique, which is clearly more efficient. But earlier, you mentioned another solution, prefix sums. Where does that fit in?
Prefix sums, they offer an even more optimized approach. But to really understand how powerful they are, we need to dig a little deeper into their concept. And we'll do just that, unpack the magic of prefix sums and how they apply to the Diffuse the Bomb challenge in the final part of our deep dive.
All right, listeners, get ready. It's the grand finale where we unlock the secrets of prefix sums and find out if they're the key to the ultimate optimization strategy. Don't go anywhere.
Welcome back to AI CodeCast for the final part of our Diffuse the Bomb challenge. We've gone from brute force to the sliding window, and now it's time for prefix sums.
Prefix sums are like the secret weapon when it comes to these problems that involve calculating sums of subarrays, and you'll see they're a perfect fit for this diffuse the bomb situation. Okay, I'm ready to see how. But before we get ahead of ourselves, what exactly are prefix sums?
So imagine a prefix sum array. Think of it like a running total of our original code array. Each element in this prefix sum array, it stores the sum of all the elements in the original array up to that particular index.
Okay, so like if we have our code array, so let's stick with our example, 5, 7, 1, 4, the prefix sum array would start with 5, right?
Right.
And then the next element would be 12 because it's 5 plus 7.
Exactly.
And then 13 because you add the 1, and finally 17 for the total sum.
You got it. So each element in the prefix sum array, it's like a snapshot of the total up to that point in the original array.
I get that part. It's pretty clear. But how does this help us diffuse the bomb?
Oh,
Especially with those pesky wraparound cases.
that's where the real magic happens. To calculate the sum of any subarray, even those that wrap around, all we need is to subtract two specific values from our handy-dandy prefix sum array.
It's like we have a cheat sheet for all the possible subarray sums.
Precisely. Let's say, for example, we want the sum of the elements 1, 4, and 5 in our code array.
Okay, the ones that wrap around.
Yeah. Now look at our prefix sum array. The last element is 17, right? The total sum.
Right.
And then look at index 1. The value there is 12. That's the sum of the elements before our target subarray starts.
Wait, I think I see it. If we subtract that 12 from the 17, we get 5, which is the sum of 1, 4, and 5. Wow, that's actually pretty amazing.
It is, right. And for the wraparound, we use a similar trick as with the sliding window, we extend the array. But instead of adding k elements, we extend it by its full length.
So our 5, 7, 1, 4 becomes 5, 7, 1, 4, 5, 7, 1, 4.
You got it. We double it up to create that virtual circular structure again.
Makes sense. And then we calculate the prefix sums for this new extended array.
Exactly. That way, any wraparound scenario, it's just a matter of finding the right spots in our extended prefix sum array. No more messing around with modulo operations or worrying about going out of bounds.
So to sum it all up, extend the array, get the prefix sums, and then just strategically subtract values from this prefix sum array to find the sum of any subarray, wraparound or not.
You nailed it. And the best part, it's incredibly efficient. The time complexity for decryption becomes ON, which is linear to the size of the array.
Way better than that brute force approach.
Oh, absolutely. And even better than the sliding window in most cases. This really shows why prefix sums are often the top choice for problems like this.
This deep dive into the Diffuse the Bomb challenge has been really eye-opening. We went from that basic brute force method, then found a smarter way with the sliding window, and finally, we landed on this super efficient prefix sums technique. It's amazing to see how different approaches can be used for the same problem, with such different levels of efficiency.
It is, and that's a key lesson for everyone listening. Understanding these various approaches, knowing their pros and cons, it's super important, especially when you're in an interview. If you can show that you can go beyond the obvious solution, that you're thinking about efficiency, that's what's going to make you stand out.
For sure. It's not just about getting the answer, it's about how you get there, the thought process, the optimization.
So, as we wrap up, let's remember what we learned from Diffuse the Bomb. Analyze the problem, think about all the different ways you can tackle it, weigh the good and bad of each approach, and always, always try to find the most efficient solution. Who knows, these skills might come in handy in a real-life coding challenge someday.
That's it for today's AI CodeCast. Hope you enjoyed this explosive deep dive into the world of circular arrays and optimization. Until next time, happy coding, everyone.